Dear students, today we'll see the multiple choice questions on the subject Fundamental of Electrical and Electronics Engineering. So here the name of the subject is Fundamental of Electrical and Electronics Engineering FEEE, and this session will be the part 2 session of our multiple choice questions. So let's see the first question. What is the purpose of grounding electrical systems? Now we have studied the concepts of grounding and earthing of electrical systems. And the options given here are to increase electrical resistance, to protect against electrical shocks, to reduce electrical resistance, to increase energy efficiency. So obviously when we studied about grounding electrical systems or earthing electrical systems, we know the main aim of it is to protect against electrical shocks. So option B will be the appropriate answer here. And the concept says that grounding electrical systems provides a safe path for excess electricity to escape. This reduces the risk of electrical shock, electrocution, fires caused by unexpected voltage spikes or short circuits. Now, excess electricity that can be due to electrical faults or it can be due to short circuits. The excess current starts flowing, so excess electricity to escape. And this excess electricity will escape to the ground, and because the excess electricity goes to the ground, it reduces the risk of electrical shock, electrocution, and fires caused by unexpected voltage spikes or short circuits. So here with this concept we can conclude that option B will be the right answer. That is, what is the purpose of grounding electrical systems? It is to protect against electrical shocks. Then we'll go to the next question. Which of the following is a common cause of electrical fires? Options are overloading circuits, proper grounding, regular maintenance, low voltage. If you see the options, proper grounding will not cause fire. Regular maintenance also will not cause electrical fire. Low voltage also will not cause electrical fire. The correct option here will be overloading circuits. So overloading electrical circuits can cause fires. When too much current flows through the wires, they can heat up and ignite nearby flammable materials. So that is, whenever there is overloading, there is a lot of current which is going to flow in the circuit, and this too much current flowing through the wires can heat up and ignite the nearby flammable materials. And that is why the common cause of electrical fires will be overloading circuits. So option A will be the right answer, that is overloading circuits. Then we'll go to the next question. What should you do if you experience an electrical shock? So the options are pour water over the affected area, apply a burn ointment immediately, remove the person from the electrical source, do nothing, it will subside on its own. So if you see these four options, out of these four options, the most immediate option which we have to do is option C. We have to remove the person from the electrical source. So out of these four options, what we have to do immediately when we experience an electrical shock is to remove the person from the electrical source. So option C will be the right answer here, to remove the person from the electrical source. Then we'll go to the next question. What does the term overloading mean in electrical safety? Options are using too many electrical devices simultaneously, using energy efficient appliances, overcharging a battery, insulating electrical wires. Obviously, whenever we use many electrical devices simultaneously, it is called as overloading. So here in electrical safety, overloading occurs when too much current passes through a circuit. This can happen when too many appliances are switched on at once, live and neutral wires touch, too many appliances are connected to a single socket. So with this concept, we can conclude that option A will be the right answer. The meaning of term overloading in electrical safety is using too many electrical devices simultaneously. Then we'll go to next question. Which of the following is not a recommended practice for preventing electrical accidents? So if you see the options, avoiding the use of extension cords, regularly inspecting electrical equipment, using damaged electrical cords, keeping electrical devices away from water sources. So out of these options, if you see, which is not a recommended practice for preventing electrical accidents. So here option C is not a practice which is followed to prevent electrical accidents, using damaged electrical cords, because if you use damaged electrical cords, it can give rise to electrical accidents. So here option C will be the right answer. So here you can see using damaged electrical cords that this practice is not done because this practice can lead to electrical accidents. Then we'll go to next question, question number 16. What does the abbreviation PPE stand for in electrical safety? The options are personal protective equipment, proper power efficiency, protective power equipment, professional protection evaluation. So here the option A will be the right answer. It is a personal protective equipment. So personal protective equipment, PPE, is clothing or equipment that protects the wearer, the person who is going to wear it, from injury or infection. PPE can protect against hazards such as physical, electrical, heat, chemicals, biohazards, airborne particulate matter, mechanical, or radiological. So all these hazards can be avoided if we use the PPE kit. So here PPE means personal protective equipment. Then we'll go to the next question. Which of the following should not be used near electrical equipment? The options are water, fire extinguisher, metal tools, insulated gloves. So it will be obviously water because water is a good conductor of electricity. And the concept says that water should not be used near electrical equipment because it can conduct electricity and pose a risk of electrical shock or damage to the equipment. Water is a good conductor of electricity, and if it comes into contact with live electrical components, it can create a path for the electrical current to flow, leading to dangerous situations. To ensure safety, it is essential to keep water away from electrical equipment and to follow proper safety precautions when working with or around electricity. Therefore, the first option, that is water, will be the right answer. Which of the following should not be used near electrical equipment? The option will be water. Water should not be used near electrical equipment. Then we'll go to the next question. What is the purpose of a circuit breaker in an electrical system? The options are to regulate the flow of electricity, to prevent overloading and short circuits, to increase energy efficiency, to generate electricity. Obviously, it is option B, that is, a circuit breaker is used in an electrical system to prevent overloading and short circuits. So here we can see the concept of circuit breaker. A circuit breaker is a safety device that protects an electrical circuit from damage caused by overcurrent. It's an electromechanical switch that automatically interrupts the flow of electric current when it exceeds its design limitations. This prevents damage to the circuit and the supply of energy to the loads. So here option B will be the right answer. The purpose of a circuit breaker in an electrical system is to prevent overloading and short circuits. Then we'll go to the next question. What is the color coding for the ground wire in an electrical system? So from these options, we can say that it is not red color, it is not black color, it is not yellow color, it will be green color. Ground wire color coding is green. So if you specifically see, the concept says that ground wire, as we have shown over here, the first option is it can be in green coding, or it can be green with yellow stripe, or it can be bare copper type. So if you see here, the first is complete green here. We can also have green with yellow stripes, or we can also have bare copper type representation of ground wire. So ground wire in electrical system is usually green or green with yellow stripe. Ground wires are also bare copper wire with no color insulation. So out of these options, what we have, option C, green, will be the correct answer. So what is the color coding for ground wire in electrical system? It is green color. Then we'll go to the next question. What does the term arc flash refer to in electrical safety? The options are a type of electrical insulation, a sudden burst of light and heat during an electrical fault, a safety switch used in high voltage systems, the process of grounding electrical systems. So if you remember the concept of arc flash, an arc flash is a dangerous electrical explosion that can cause serious injury or death. It occurs when an electric current jumps through the air from one conductor to another or to ground. This can happen when an electrical system has a sudden high voltage surge or short circuit. Arc flashes can generate heat or temperatures of up to 20,000 degrees Celsius, light, very bright ultraviolet light, pressure, arc blast pressure is caused by the rapid expansion of gases and conducting materials. Arc flashes can occur in large switchboards, smaller switchboards, electricity supply pillars, large electrical equipment. The release of energy creates a bright flash of light and heat, which can cause burns, fires, explosions, serious injury, or death. So, therefore, here the term arc flash in electrical safety means a sudden burst of light and heat during an electrical fault. So, option B will be the right answer here. Thank you, students.